Today we will cover learning about the different parts and properties of isosceles triangles and equilateral triangles. So first, let's start with the vocab. An isosceles triangle is a three-sided polygon in which at least two sides are congruent. So we have an isosceles triangle here. These tick marks tell me that these two sides are the same. Then the different parts of this triangle, we have a vertex. The two congruent sides are called the legs. The two angles that's not the vertex are called base angles. And the side opposite my vertex is called the base. So we have two theorems associated with isosceles triangles. First, the isosceles triangle theorem tells me if two sides of a triangle are congruent, then the angles opposite those sides are congruent. What that means, if you are given a triangle and the only thing they told you is that these two sides are the same, there's no other markings here, no other information. Because these two sides are congruent in a triangle, that means these two angles have to be the same. So with regards to my picture, my two sides here, we have AC on this side. If AC is congruent to BC, then that means my base angles CAB is congruent to angle CBA. Now the converse of that is true. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. If you are given a triangle and the only bit of information they told you is that these two angles are the same, nothing else. Because it's a triangle with two angles that are congruent, that means these two sides have to be congruent. With regards to my picture back up here, if angle CAB is congruent to angle CBA, then that means side AC is congruent to side BC. Next, let's talk about equilateral triangles. If a triangle is equilateral, so you have a triangle. If it's equilateral, they told you these three sides are the same, then it is also equiangular. If these three sides are the same, that means these three angles have to be the same. The converse of that is also true. If a triangle is equiangular, that means these three angles are the same, and that's all they gave you. Then that means these three sides have to be the same as well. It is also equilateral. Each angle of an equilateral triangle measures 60 degrees. We know that because the sum of my three angles is 180. I have 180 degrees. We divide it into the three equal angles. It gets me my 60. So those are the properties of isosceles triangles and equilateral triangles. So let's go ahead and do some examples. Alright, number one. First, I'm focusing on the triangle on the left. So what I'm gonna do is cover up this part. I don't need it just yet. Because these two sides are congruent, that means my two angles over here are congruent. With those two angles congruent, I can now go ahead and say that if my angle up here is 11x plus 10, that means my angle down here is also 11x plus 10, which leads me to the equation 9x minus 26, my vertex, plus 11x plus 10 plus another 11x plus 10, my two base angles, and the sum of the angles in my triangle is 180 degrees. Alright, combining like terms, 9x plus 11x plus 11x, that gets me 31x. Then I have a minus 26 plus 10 plus 10, that gets me minus 6 equals 180. Adding 6 to both sides, and we get 31x equals 186. And then dividing both sides by 31, we get x equals 6. Alright, so the same idea happens for y. These two sides are congruent. That means this angle over here is congruent to this angle up here. So if my bottom angle is 9y, that means my top angle is also 9y. So I would like you to pause this video and spend a moment to go ahead and write the equation. Alright, so the equation should be 7y plus 5, the vertex, plus 9y, all three angles add up to 180. Go ahead and solve for y. I'm going to pause this video. And y equals 7. Alright. So example 2. Here we go. So this time, this 28x plus 27 is not an angle. We know that because it's outside the triangle. If they were angles, we would either write them inside the angle or something like this where it has an arrow pointing to the angle. This one is outside, so it's referring to this side right here. According to my diagram, 28x plus 27, that side, and the side 40x minus 9, they're congruent. These tick marks tell me they're congruent. Because they're congruent, that means these two are the same. So my equation is going to look like 28x plus 27 equals 40x minus 9. Alright. For this one, I'm going to solve this by hand the long way. Subtract 28 both sides because I want to get x by itself. So we have 27 equals 12x minus 9. Now I want to add 9 to both sides to get 36 equals 12x. And finally divide both sides by 12 to get x equals 30. So now that we know what x is, we can go ahead and solve for the angle. So first let's figure out what my vertex angle is. We know x is 3, so we can plug 3 in there. 30 times 3 plus 13 gets me 103. That tells me this angle right here is 103 degrees. So now here's the thing. Because these two sides are congruent down here, that tells me this angle and this angle have to be congruent. It's an isosceles triangle. I have 103 degrees. All three angles add up to 180. So I can do 180 minus 103 to get me 77 degrees. That means I have 77 degrees left to split between these two congruent angles. 77 divided by 2, because these two are the same, gets me a 38.5. So right here is 38.5. And finally, this goes back to the exterior angle theorem. I have 103 right here, 38.5 right here. My two remote interior angles should add up to equal the one exterior angle over here. So my equation now is going to look like 103 plus 38.5 5 equals 15y minus 1. And just like with what we've been doing, combine like terms, solve for y, all that good stuff. Alright, let's move on to the back. Alright, find the values of these numbers, x, y, and z. Okay, so for this one, number 3, first idea I have is I see these congruent angles. Because these two angles are congruent, that means they're the same. So my equation is 8y minus 7 equals 6y plus 5. Go ahead and solve for y. To get y equals 6. Alright, now that I know y equals 6, let's move on to trying to figure out for x. Again, this skinny triangle right here is an isosceles triangle. Those tick marks tell me so. So if right here is 4x, right here is also 4x. These two sides are congruent. That's something we're about to use. So my equation goes back to the exterior angle theorem. The two remote interior angles, 8y minus 7 plus 6y plus 5 equals the one exterior angle, 4x. And we do know what y is, y equals 6. So we can go ahead and plug in 6. 8 times 6 minus 7 plus 6 times 6 plus 5 equals 4x. Alright, plugging in 6, this is what we have. 48 minus 7 plus 36 plus 5, that gets me 82 equals 4x. And dividing both sides by 4, we get x equals 41 halves or 20.5. Alright, next, number 4. For number 4, the different thing here is we have an equilateral triangle, and as we mentioned earlier, in an equilateral triangle, it's also equiangular, meaning all of the angles are 60 degrees. So, this helps us figure something out up here. If this part of the triangle is 60 degrees, and we know this box tells me right here that it's 90 degrees, we can do 90 minus that 60, which tells me this part of the triangle is 30 degrees. Alright, we know it's 30 degrees, we know it's 4x minus 2. So my equation now looks like 4x minus 2 equals 30 degrees. Adding 2 to both sides, we get 4x equals 32. Dividing both sides by 4, we get x equals 8. Same deal with the other side for the y. If that's 30, these two angles are congruent because it's an isosceles triangle. So if that's 30, that means right here is 30. And my equation again is 7y plus 9 equals 30. Subtracting 9 from both sides, we get 7y equals 21. Divide both sides by 3, we get by 7, we get y equals 3. Alright. So go ahead and here's example 5. Take a look at it, figure out what you need to do. I'm going to pause this video, and when you pause this video, see if you can come up with the equation of where to start. My suggestion solve for x first, which will let me know what the number angle is down here, which will let me know this angle over here, which lets me know what y is, which lets me know what z